How's it going, guys? Today in this video, we're going to be going over Module 13.2, Day 2, where we're going to continue talking about graphing exponential functions. So in this video, we're actually going to be talking about how to get the function or how to graph an exponential function. And what's different here than what we're used to seeing is that we have a different transformation rule. Usually, we have the transformation rule bx plus h, comma ay plus k, but now we're going to be using a new rule of x plus h, comma ay plus k. And if you remember from the previous video, the previous notes on 13.2 day 1, when we listed out all our transformations, we didn't have any horizontal stretches or horizontal compressions. And that's why we don't have a b value in the x term, an x part of the transformation rule. Because we don't really deal with horizontal stretches and compressions with exponential functions, so we don't put that into our transformation rule. So let's go on to an example to see how to actually do these. In number 1, we have the function -3 times 2 raised to the x minus 2 plus 1. And we're going to fill this out and figure out the domain, range, graph our new function, in our asymptotes, and list all the transformations, all that good stuff that you see in front of us. But before we actually do that, I want to kind of remind you guys of what our general equation is when it comes to exponentials. So it'll be g of x will equal a times b raised to the x minus h all plus k. One thing to take note of is that in our equation, we don't have 1 over b anymore, it's just b. So when we list out our parameters, our a is -3, our b is our base, which is 2. We don't flip it anymore, it's just 2. Our h is also 2, and our k is 1. So if you list out our transformation rule, it's going to be x plus h, or x plus 2, comma ay plus k, or -3y plus 1. For our domain, remember, no matter what transformations we do on an exponential function, our domain will always be -infinity to +infinity. Our range, since our a is negative, our range is going to be y is less than our asymptote of k. So in this case, our range is y is less than 1. Is it a growth or decay function? We'll come back to that in a bit once we actually graph our function. But before we do that, we know what our asymptote is. We just talked about that. Our asymptote is always y equals k. So in this case, it's y equals 1. And now we have 2 reference points here for our parent function for our b of 2. So we can take these points, plug them into our transformation rule to get our new transform points. So for 0, 1, we put that into our transformation rule. We get 0 plus 2, comma, -3 times 1 plus 1. And we solve this out. You get 2, comma, -2. So that's one of our transform points. And now let's figure out what our next transform point is. Our next point, we're using the reference point 1b. So in this case, that'll be 1, comma 2. So those are going to be our 2 reference points. And now we're going to plug in 1, 2 into our transformation rule. And that'll give us 1 plus 2, comma, -3 times 2 plus 1. And that'll give us the point 3, comma, -5. So that's our 2 new points. And we have our asymptotes. So let's go ahead and just graph our function. So first thing we want to do is we want to graph our asymptote. Our asymptote is at y equals 1. So that'll be right about here. Next, we're going to plot our 2 new transform points that we found. We have 2, -2, and 3, -5. And if you remember kind of what these functions look like, we know that it starts near the asymptote and we go away from it. That's drawn terribly, I didn't even hit the points, but go through the points, it's going to look something like that. You go through the points and it goes down and to the right forever. All right, so that's more or less what our function is going to look like. So now we need to figure out if it's a growth or decay function. And what that means is a growth function grows away from the asymptote. And we can see here in our function that we start near the asymptote and we start shooting away from it. So that means we're growing away from it. So in this case, this problem is going to be a growth function. We actually haven't seen what a decay function looks like yet, but we will see that in 13.3, and you'll see how we start away from the asymptote and we grow towards it. And we'll see what that looks like in 13.3. So last thing we want to do is we want to list the transformations. So our transformations, we have a vertical stretch. Since our absolute value A is greater than 1, we have a reflection over the x-axis. And that's because our A value is negative. Our H is 2, so we go to the right by 2, and our K is 1, so we go up by 1. And that's what, or how you'd solve a problem like this. So for number 2, I want you guys to pause it yourself, or pause the video and try it out yourself. I'll post the answer up in a bit, and we'll go over it. All right, this is what you should have gone for number 2. Our A value is 1.5, our B is 10, that's our base. Our H is positive 3, that's when you have the x minus h. Our K is negative 5. So our transformation rule, remember we're using our new rule of x plus h, comma ay plus k. And when we use that new transformation rule, we get x plus 3, comma 1.5y minus 5. Our domain, like we said before, it will be all real numbers. No matter what transformations you do to the parent function, the domain is going to stay the same. So we get negative infinity to positive infinity, or all real numbers. Our range, since our A is positive, our range will be y is greater than our k value. Our k is negative 5, so our range is y is greater than negative 5. For our 2 reference points that we have from our parent function, we have 0, 1. That will transform into 3, comma negative 3.5. And then for 1b, that's the same thing as 1, comma 10. That's going to transform into 4, comma 10. Is it a growth or decay function? I already have it graphed out, so you can kind of see that we grow away from the asymptote. So that means it's a growth function. And our asymptote, that's y equals k. So in this case, it's y equals negative 5. And for our transformations, we have a vertical stretch. We go to the right by 3, and we go down by negative 5. One thing I want to point out really quickly, or not really point out, but just kind of let you guys know, is how to know if it's a growth or decay function by just looking at the function. So it's going to be a growth function if the absolute value of b is greater than 1. And it'll be a decay function if the absolute value of b is less than 1. Or in other words, when b is greater than or equal to 1, or not equal to 1, b can never equal 1. But when b is greater than 1, or when b is less than 1, it's a growth function. And for decay, if b is greater than negative 1 and less than 1. That's how you know if it's a growth function or a decay function. All right, so let's keep on going. Example 3. Here we're going to write the exponential function when given a graph. We're going to be working backwards, right? I'm given the graph this time, but we're going to work backwards to figure out what our function is going to be. So on number 1, we're told b is 2. And we look at the function. We're given that our k value, our asymptote is y equals 1. We know our asymptote is always in the form y equals k. So our k value is 1. So for our first reference point, that's even the reference point with the smaller k value, or the smaller x value. So our first reference point is negative 1, 3, and the y value will also be negative 1, 3. So what we're going to do here is we're going to figure out our h and our a value by using our first reference point. So if we go back over here, we know that if we have our first reference point of 0, 1, that's from the parent function. If we plug this into our transformation rule of x plus h, comma ay plus k, that's going to shoot out our transform point. In this case, our transform point is this negative 1, 3, comma negative 1, 3. So that's how we're going to figure out what our h and our a is. So looking at this over here, when x is 0, we plug that into x plus h. That'll give us negative 1/3. So 0 plus h will give us negative 1/3. And at the other time, and also on top of that, when our y value is 1, we put that into ay plus k. That'll also give us negative 1/3. So we know a times 1 plus k will give us negative 1/3. Or in other words, h is just your x value of your first reference point. So h is negative 1/3. So you can put that in over here. In our a plus k term, that's going to be the y value of your first reference point, which is also negative 1/3. To figure out our a now, we can actually plug in our k value, which we know from our asymptote, into this equation here, our a plus k, to figure out what our a value is going to be. So if we do that, we have a plus 1 equals negative 1/3. We minus 1 on both sides. We get that a equals negative 4/3. So now that we have our a value, our k, h, and we know what our b is going to be, we can plug this all into our equation to figure out our general equation for this function. So we get that g of x will equal our a value of negative 4/3 times our b value, which we said is 2, raised to the x minus h. Our h is negative 1/3, so we get plus 1/3, all plus our k value of 1. So that's what our general equation is going to be. All that's left is to figure out what our domain is going to be in set notation. So remember, no matter what transformations we do to an exponential function, it will always be all real numbers. So that's what our set notation for the domain is going to be. And for our range, our a value here is less than 0. So that means our range will be y is less than our k value. So in set notation, we get y such that y is less than our k value of 1. And that'll be our range. And so for number 2, or the second example of a problem like this, I want you guys to pause the video, try it out yourself, and in a couple seconds I'll post the answer and we'll go over it together. All right, so this is what you should have done for number 2. Our asymptote is y equals 6, so that means our k value is 6. Our first reference point is negative 4, 4.4. And remember, our first reference point comes from 0, 1. So if we plug this into our transformation rule, it should shoot out this transform point. Our first reference point we see on the graph, that's our first transform point that came from 0, 1. So you plug in 0, 1 into our transformation rule, it shoots out negative 4, 4.4. And like we said in the previous slide, that your x value of your first transform reference point is your h value, so our h is negative 4, and our a plus k is the y value of our transform first reference point. So a plus k equals 4.4, our k is 6, we solve for a, we get that a equals negative 1.6. So our equation is going to be, it says f of x, but it should say g of x. So g of x will equal negative 1.6, parentheses 10 raised to the x plus 4, all plus 6. Our domain, it's not going to change. It's still going to be all real numbers. And our range is y is less than 6, and that's because our a value is negative. So y is less than k, and our k value is 6. All right, so that's the video, guys. Really just, hopefully this helped, guys.